present our COA assignment, that is addition of two 8-bit numbers on the 8051. Inputs are at 70H and 71H, and the sum goes to 72H, and the carry, if there's any carry, it will go to 73H. And our team members are Akshata AB, Deepa M, and I am Kirtana B, and Manasa KG. So this is my assembly program, and we load the first number into the accumulator and the second number, and we store the sum at 72H. Then check the carry flag. If there's any carry, that is 1, it will store to 01H and at 73H, or else it will just go to 00H. And to run this program, we first build the project, and we carry flag. If there's any carry, that is 1, it will store to 01H and at 73H, or else it will just go to 00H. And to run this program, we first build the project, and we build the project to make sure that there are no errors, and we paste the code which has the extension of .asm, and then we save it as a file .asm, and then we translate it to check there are any errors, and then we build it, then we rebuild it. So as we can see here, there are no errors. So now we are open to, then now we can start the debug session so that we can run and watch memory and flags. And now we have to view memory window, and then there we have to open memory 1. Then at address we have to give D:70H, and then we have to give two inputs, that is which is in our assignment title, that is addition of two numbers, two 8-bit numbers. So we give input as 22 and 24. Now to check it, we run our program step by step. It will add the two numbers and update 72H and 73H. The sum at 72H is 2DH, which is 46 in decimal. Since 46 fits in 8 bits, carry is 0. So 73H is 00H, and the carry flag is clear. Now we can also check by changing the inputs given, that is 22 and 24, and we can run program again by saving. We should first save the inputs to run program, and then we can run step by step. At 73H, we'll get the addition of two numbers, that is the sum. To summarize, we added two 8-bit numbers, stored the sum at 72H, and saved the carry at 73H. This demonstrates basic arithmetic accumulator usage and flag checking on 8051. Thank you.
Hello everyone, myself Akshita, and this is our code. In this code, the first line tells the assembler to start the program at memory address, and it is the starting point of the code execution. Here second line move A70H, and here it tells us move the value stored in the RAM location 70H into the accumulator A. So A is equals to 70H. And then add the value in RAM location 71H to A. The result is stored back into A. During addition, if there is a carry, it sets the carry flag CY. So 70H plus 71H is equals to A. Then store the result of the addition into RAM location at 72H. So 72H now contains the sum without carry. If the addition produces no carry, the program jumps to the label called no carry. This runs only when there was a carry. It stores 1H in RAM location 73H to indicate carry is equals to 1. A short jump to stop label to avoid executing the no carry section, and then runs only when no carry occurred. Stores 00H in memory location 73H to indicate carry is equals to 0. Then last step stop. It is an infinite loop and it keeps the program from running into empty memory. And this is how we run the code. First, save the code and translate it, and then rebuild it, and then we have to batch it. Next step is to debug and start and stop debugging section. And here the address is d:70h and enter the values like 2 and 4, and this adds and it gives the answer first. And save and run this code. This comes the output as 6 and next stored in 73h. Thank you.
Hi, I'm Mansa. Here is the explanation of our code. Uh, First line of our code tells us this tells the assembler to start the program at memory address, and it is a starting point of the code execution. The next line move A70H is a move or copy the value stored in RAM location 70H into the accumulator A. So A is equals to 70H. The input given, our input given is 70H. And next line add A71H tells add the value in RAM location 71H to A. Result is stored back into A. During addition, if there is a carry, it sets the carry flag so that A is equals to 70H and as well as 71H. Next, move 72HA. This means to store the result of an addition into RAM location 72H. So 72H now contains the sum without carry. Next, next line tells us if the addition processed no carry, the program jumps to the level no carry. If a carry did occur, this jump to skip and program continues to the next instructions. Next, next line tells this runs only when there was a carry. It stores 01H in RAM location 73H2 indicates carry is equals to 1. Next line, a short jump to stop label to avoid executing the no carry section. No carry. Next line tells runs only when no carry occurred. Stores WH in memory location 73H to indicate carry is equals to 0. Next stop. Next line shows infinite loops keeps the program from running into empty memory. Next we can summarize this in a simple like word. The program adds the value stored in 70H and 71H. The sum is stored in 72H. If the addition processed carry, then 73H. If no carry, then 73H is an like okay. Program stops by looping forever a stop. First, we have to save the code. Next, we have to translate this, and next we have to build, and next rebuild. Next patch build, and next we have to go for debug and start stop debug section. In this we have to go for memory, and we have to type 70h d:70h, and we have to put some input like 10, and the second one as 20. So now we have to save the input. It's saved. So now we have to run this line to line. Now we get the output as 30. Addition of 10 and 20, we have given 71 70h as 10 and 71h as 20. We have no carries here, so we have 30 as an answer. And this is our explanation of our code and the output. So thank you.
I am Deepa M and this is our code. First, ORG this tells the assembler to start the program at memory address OOOH. It is the starting point of the code execution. And the second line, move A70H.
Move the copy the value stored in RAM location 70H into the accumulator A. Add A 71H, add the value in the RAM location 71H to A, and result is stored back into a A. During addition, if there is a carry, it sets the carry flag CY. Move next, fourth line, move 72HA. Store the result of the addition into RAM location 72H. So 72H now contains the sum without carry. And the fifth line, J and C, is jump if no carry. If the addition proceed no carry, the program jumps to the label no carry. If a carry did occur, this jump is skipped and program continues to next instructions. Move 73H #01H. This runs only when there is a carry. It stores 01H in RAM location 73H to indicate carry is equals to 1. In the 7th line, a short jump to stop label to avoid executing no carry selection, and in no 8th line no carry. Move 73H #00H runs only when no carry occurred, stores WH in memory location 73H to indicate carry is equals to 0. Then 9th line shows that SJMP stop infinite loop keep the program just from running into the empty memory. And this is the code. And first we have to save the code. Then we have to translate the code. Then we have to build the code and rebuild the code and batch build the code. Then we have to debug the code. Then we have to store the values in the D70H. Then we have to put in 71H and 72H. The result will be in 73H. And the output is 6. This is the code. Thank you.